Okay, let's see. Let's see. All right, class. Good afternoon. Are you still doing okay? I hope you're well. And does anybody want this recording? You might notice. I'll just tell you. I'm not introducing any new topics this semester. We have today and one and next week. I stopped introducing new topics. We're going to review things today and get ready for tests on 2 different days. That's a big one. Okay. So if you want to record it, tell me. I'm not proprietary type person. Let's do, I want to switch. You don't want to see me because it's better to learn something. Okay. Let's see. Announcements. Well, today is May 5. Do you know that on May 5, what's special about May 5? May 5 is the day, one day of the year, that all the climbers go to the top of Mount Everest. That's the day. It seems like Mount Everest has horrible winds, icy cold winds, 364 days a year. But one day of the year, and it's usually May 5, all the winds stop. So you can get to the top. Okay, let's go on. May 5. What do we have coming? We are section 5. 5 and 5. Not visible. So we have a test coming May 12. And what did we agree on last time? Oh, this is just class time, 2 to 5, 2 to 4. We'll talk about it later. The following week we have the programming test, and that has an extended hour. But next week it's just 2 to 4, and that's concepts. And my promise 3 weeks ago was that it can't be because of the time crunch. It can't be as long as the midterm. The midterm was 28 questions. This will be about 14. We'll keep it under 14 questions. So it's going to cut in size by half. Okay. The questions could come from the whole semester, but obviously, predominantly, they're from the second half. What are some things we did in the second half? Recent history. Recent. Well, do you remember I talked about inline assembly. And then I talked about pure assembly. And by the way, I've even forgotten. I was surfing through the class website. There are 2 programs of pure assembly posted. 2 programs there. I don't really believe in it as a tool for teaching, but there may be some corporations that actually use that. Where I think they might use it is in device drivers. Device drivers don't have an operating system, so you're kind of left with, man, what do they have? They definitely don't have libraries of functions. So I'm going to leave it there. I don't know what they do, how they're doing that. But they don't have any C++ or compilers or libraries of pre-built functions. They're just all by themselves. Okay, do you remember about, there was a discussion how to add a large float with a small float. And the farther apart they are, the more precision you lose. To maintain full precision in a computer register, they have to be really pretty close together. The best case is where they have the same stored exponent. Or next best case is their stored exponents are not too far apart. Then they add very well. But once they start to separate a lot, the end result is usually the small one never gets added in. Okay. Then you remember the list of ARs. That was a discussion one day. And I posted the software from which I make AR, from which I make the list. And software, and if you go looking for it, its name is StackFrame. So you should ask your SI instructor to find the list of ARs inside of a StackFrame, and he'll show you the techniques again. You got to get good at it. That's not a programming question. That's a concept question for next week. Okay, and what else did we do? Oh, there was a day we spent on extending size of storage. Extend size. That means bits, or I'll come back to storage for a number. So remember, if you store 27 in a register that's currently 16 bits, how do you convert it to 27 in a register that's 32 bits? Okay. There's a whole discussion on how to do that. Sometimes it overflows into 2 registers, and then there's a special instruction that keeps it all within 1 register. I think that's, oh, and then that's almost my list here on the side. There was something about subnormal numbers, and that's going back about 3 or 4 weeks ago. Normal numbers. Okay, then there's stuff that's came after the midterm. Next week, Tuesday, will be all on concepts. This whole class meeting will be about concepts. Okay, so let's see. I have some other agenda right now. It's about programming. Don't forget, this is another announcement. Soon there will be no more SI meetings. So there's one today at 5:15. And the Zoom number is 886-115. And it is 81134. Okay. Any questions? No questions. All right. Okay. And I'm going to talk about programming issues because I've been reading a lot of submitted homework, not homework, submitted midterm programs. Okay. Now, what I'm going to talk about applies to a minority, like 20% of students. So the other 80% of you, you just follow along for what it's worth. But I got to clarify a lot of messy programming. So where's my list here? I'm looking on the side to find my, that's not it. That's not it. Okay, I know what we're going to do. Yeah. Okay, so this all started because in the 3 sections of assembly, there's now about 90 students total. I don't see you every day, but I think you're still enrolled. About a certain portion of those programs submitted for midterm were real junk. And it's driving me bonkers to have to stare at it. Some were beauty queens. I like those, but some were real junk. See, to evaluate a program, it's not enough to say mine works. Got a right answer on one test case, so mine works. I'm all done. It's like cars. You can have a junk car. What's a junk car? I don't want to pick on anybody. A 69 Ford pickup or something. You get out of junkyard. It will still get you from here to Disneyland. But a Ferrari will get you from here to Disneyland too. That's like saying, it got me there. Okay, so it's a great vehicle. But there's difference in quality between those two, even though they can both carry the passenger to the destination. That's true. There are 2 programs. They can both produce the right output, but one's junk and one is Ferrari quality. So I'm trying to address those who are sending me junk. Got it? Okay. So programs can be low quality and high quality. Low or high. In the evaluating quality is not, it runs. That's important. It's important your vehicle get you to your destination, but that's not all you want. You want some comforts beside that. Okay, so here I gotta lay the background. So take about 15 minutes. Some researchers a long time ago, some computer science researchers proved that all programs if reconstructed properly, can be built out of 3 things. There's only 3 that build all programs that were ever made in the past and all programs that will ever be made in the future. And another student asked me, what about if it runs in a quantum computer? I honestly don't know, but all von Neumann computer programs can be built out of 3 things. Okay, so here's the three things. One is called the sequence. This is really so elementary. I don't know why we have to even study it. The sequence says you just put in your source file a sequence of one statement, one statement, one statement, one statement in sequence, and that executes. And it has a picture. That's symbolic of it. That's called that's the box is a statement or group of statements, and then a group of statements, and it just executes all the way from start to return statement. Okay, the other one, the second of the three, we know it as the decision, and that goes as a picture. And when the computer decides something, it's a diamond shape, and decides yes, because there's a true false question in the middle, question mark, or no. And if the answer is yes, it does a sequence over here. And if the answer is no, it does a different kind of sequence over here. But in the end, it all comes back together and life continues. Okay, that's a decision. And the third one is iteration, looping. Okay, so it has its picture. The flow of control is flow of execution is coming along, and then it reaches the loop control statement, the loop control condition, and it's since it's a question mark what to do, we still draw it with a diamond, and you test the condition. The condition is, should I stop or continue? So if you continue, or you might stop, then if you continue, you execute the body of the loop. And then once you do that, you go back and you join in to here. And if it stopped, you just go out and you go on your merry way. Okay. There's a cousin to this one where it's drawn upside down. That's where you execute the body of the loop first, and then you decide, should I continue? Does it meet the condition? Condition question mark. If the answer is yes, the condition is still true, I'll put T for true. You go up here and you join this. And if the condition is false, you can't continue, then you go out like such. It's the same loop, just drawn upside down. So anyways, there's a story here. If I put a box around this, I wanted to make a nice rectangle, but I can't. Okay, and this should go out like that. Okay, or let's do this back here. Put a box around this one, or put a box around this one. There's a property they all have in common, and here it is. In entering the red box, there is one entry place and there's one exit place. In entering this red box, there's one entry place and one exit place. Entering this one, there's one entry place and there's one exit. I didn't draw it over here, but the same story holds. There's one entry up here, and if I put the box around it, there'll be one exit place out of it. Okay. When you build a big program, and you turn into me, then I'll show you. I sometimes draw the diagram to see if your code is up to quality of a Ferrari or is it a worn out pickup from 1960. So when you get the whole program, then if I diagram it, there would be a start here. And then there's a welcome message usually, and then there's a prompt. And then there's an IO device where you input something. And then maybe it's you're inputting 5 numbers for an array. There'll be a loop structure. And the program goes on. There's other stuff that's going to happen. There's going to be, oh, I never drew a switch statement is actually compound nested if else statements. There's a symbol for, in professional program, there's a symbol for a switch. It's looks like this. You name the switch variable like account number, or that's not a good one, day of the week number or something. And then you get say 4 choices. So out of this choice, if this one is true, it's 1 or 2, then you do this one. And if it's 3, 4, then you do this block of code. And if it's 5, you do this block of code. And then this is something else. This is the 7th day of the week. And then you do this one. And you know what? When you're all done, they all join together again. And execution continues after that. And you know what? 1 entry, 1 exit. So, and then finally the program reaches its end. And then there's RET, or return spelled out. Okay, so did I just see if I put my hands on it quickly? I don't know where I laid it down. I can't find it. Oh, this might be it. I don't outline all of your programs, but sometimes they look suspicious, and I do. And I determine what level it is. Is it a junk car or is it a great one? I don't know. This is written in ballpoint pen, but I was outlining one student's program here. And there's the flow of control. When there's double edges on the side, then I know that means it's a call to an outside function. So he's calling scanf here and isFloat here. And there's a decision, and we decided to call isFloat on the second number. But if isFloat was false, it follows the side path over here. And it went on to the next page. Side path continues. This program I outlined actually turned out to be really nice. Here, this got my scribble in there. And then here was a switch statement. If something is negative, equal to 0 or positive, you do different actions here, but they all came back together. And then it continued. And all those lines came back together at a junction place. And then it says restore the stack, restore the GPRs, and then it says return. It turned out to be really nicely organized and quality program. Those lines never cross. If you watch that, in this example, they never cross. And it was a good original program. Same story. They never cross. You may have branches that go out to the side and come back later, but they don't cross over each other. So I don't. I'll be embarrassed to show you. Then I come to other programs that are submitted, and I don't know where you students learn those kind. I don't believe it came from Cal State Fullerton. You drug it in from somewhere. I drew the diagram. There was a spaghetti of lines crossing each other all over the place. There was here, see if I can explain. This is poor quality. How do we do this? You start someplace. I'll just symbolically say the program is executing statements here, and then it's called something called search. So I thought, up here in the directives, compiler directives, there will be an extern search. But there isn't, no such thing. So I do a search and find in the text editor to find where is search. Well, it's 30 lines down in the middle of this same program. It says search with 2 dots on it. And then there's a bunch of statements here. And then there's RET. And then there's some in-between stuff here. But there's other in-between stuff here. And so when execution comes down here, it reaches this and it executes this a second time. And there were other commands in the middle with find. And then this one had some statements and a return in there. And there are more statements after that. And then inside of here, for instance, it'd be call search. And this search is supposed to be a function, but it has no push the 15 registers. It doesn't have the 15 pops. It's like stuck in the middle of some other program. And after a while drawing lines, I couldn't unravel what the whole meaning was. So I don't know where this individual learned all this, but it made no sense at all. The lines crossed over everywhere. It was unmappable. So I know I'm talking to the 20, this is for the 20% who learn programming somewhere else. Most of you, I think, are pretty good computer scientists, but I need to help those who are confused. This is not programming. This is a 1936 Chevrolet truck that's been rusted to death and is ready to fall apart. That it may still get you to your destination, but it isn't worth 2 cents to even keep that in your hard drive. So we need some basic rules to avoid this mess. By the way, it did segfault somewhere in the middle of its execution. I'm not surprised the computer couldn't even follow it. Okay, so we need some rules of programming. Programming is half a science and half an art. The art is putting the pieces of the puzzle together correctly so the desired picture is made at the end, just like a desktop puzzle picture. So that's the art, is putting them together, but the science is you do it in such a way that someone who comes later will say, that makes sense, I can understand what you did. This one that I described here, even I can't make sense. I never did make sense of it. Of course, it got 2 points in scoring, 2 points out of 100. Okay, so rules of good programs. Let's set up some good things we need. Okay, one is there can be only one return statement. one RET, or if it's another language, spell it out. Turn. And the counterpart is there's only one place to start. By the way, this person had declared several globals at different places. You didn't have to start your call directly below the word segment text. You could start it in the middle of the function if you wanted to. Okay, there's only one return. There's only one global. And the declared global is directly underneath the word segment text. That has a name. That's called the entry point. Entry point is only after segment text. Now, I grant you, most of you do that properly, but there's the 20% that I'm worried about. Okay. Now, when you're beginning, this is an overly strict rule, but as startup programmers, you should follow it. One function to one file correspondence. One function matches or is stored in one file. Okay, I'll relax that in just a moment, but that's the basic rule we teach beginners at the very start is you put one function in one file and that's it. It's a one-to-one correspondence. Okay, I've had turn-in programs where the driver file has a main and it has three other functions in there with main that are part of solving the problem. That is just, that's junk vehicle. It's time to take it to the scrapyard. Okay, one function matches or is equal to one file. What else do we need to know? There was another, let me look at the basic rule set. Did I put that? Oh, there we go. Here we go. If there's a call statement, a call statement, then this, I guess this is somewhat redundant. Then it references a function with the complete set of general purpose register backups and general purpose restores. Then it calls, it references I'll make it a genuine function. That means it's going to create an activation record. It's going to do the 15 pushes. It's going to initiate a sequence of actions, decisions, looping, and straight line code in sequence, and it's going to pop those pushes to restore the general purpose registers. It's a genuine function. This calling someplace inside your same, it's worse than inside the same file. It's calling a place inside your same function. That isn't even recursion. That's calling yourself. It's calling a piece of your function inside of itself. That is going to get you a 0. So if a call statement calls a real function, not just a piece of the code that you happen to be working in. A genuine function is what we talk about all the time. A genuine function creates a new activation record. It pushes the the resumption address onto the front end of the old activation record, and it puts the back end's address as the start of the new one. It does all that work. Then if you're going to use a call, do that. If you want to kind of fake it around that, then try, I don't like it, but it's legal. Try JMP as a replacement. If you want to go to another part of your same program and execute that and possibly come back, go ahead and jump to it, execute it, and then you jump back. Doing a jump does not create an activation record. Okay. There's something more. Only one global per file, only one function per file. I want to one return statement in the entire file. Your blocks of code have, I kind of showed that, have one entry, one exit. Like these things have one entry. If you put your eyes and you just focus on a piece of it, there's not a thing that comes in here, and there's two different ways to enter this block. That's not good programming. That's junk programming. Okay. Let's see if we're getting there. No, something. Okay, last one is some few people, I don't know, you learn something in another campus or another university. Make your program out of the instructions that we've learned this semester. Use ASM from this course. There are hundreds of many other instructions that you can drag in, but it's at great risk. They weren't going to do what you expected. So earlier I tried to come up with the full list of everything we did this semester. There's about 40 on the list, plus or minus one or two. So this, you don't need to Photoshop shoot this one because I posted it online. You can get a nice clean copy of all the instructions we've ever used this semester. And it's nicer than my handwriting. These are the general purpose register instructions, like push, pop, move, add, subtract, mul, imul, div, idiv, neg, not, or, and, xor, je, jl, jgg. And don't forget this is for general purpose registers. Compare, index, shift right, shift left. Don't forget the extensions, CQO, CDQ, CWA, CBW. And then here are the other jumps. This is now floating point ones. This is for XMM registers. JA, JNA, JB, JNE, JNB. How about just JE? Okay. We didn't do this one, but someone had asked me about, that's called rotate to the right, rotate to the left. I don't think you need it, but it works on general purpose registers. Okay, so this full list has been posted near the same place where you get your homework, get your program specifications. You should get a clean copy. And you know how shifting left and shifting right works. What does shifting left do, or shifting right do mathematically? Shift right RBX3, or shift left RBX2. Okay. I'll tell you what it is. This is one of those tricks they do. Let's see. So here's RBX, and I'll make up a number 1 0 1 1 1 0 1 0, and you do the shift right. Let's do this one first, and then the other one will fall out easy. If you say shift to the left 2 spaces, what you get is 0 0 1 0 1 1 1 0, and 2 of them got thrown out to outer space. These 2 got lost. Well, if you wrote it out in decimal, whatever this number is, this one is 4 times larger. Okay. It's like this. Take the top number 0 1 0 1 1 1 0 1. The number 4 is 1 0 0. And if you do multiplication, well, I get a line of zeros. Then I multiply by the next 0 and get a line of zeros. And then I multiply by the 1 and I get 1 0 1 1 1 0 1. And then I add and I get 0 0 1 0 1 1. How many ones? 1 0 1 0, something like that. I get the same, I get this number. It's been, there it is, moved over by 2. And what I did was multiply by 4. So if shift left produces the same result as multiply by 4, what does shift left by 3 do? What does shift left by 4 do? Yeah. Okay, talk to me after the whole lecture's over. Okay, the answer is this is multiplication by 4, this is multiplication by 8, this is multiplication by 16. The next one would be multiplication by 32. It's shift, here it is, shift RBX by N is the same as RBX equals RBX times 2 to the N. That's not assembly syntax, but it's telling you what happens. This is multiplication by 2 to a power, and that power is that number. Division is shifting the other direction to the right is division by a power of 2. Okay. So shifting right, that means RBX divided by 2 to the 3. And it gets the same answer. Now, for speed contests, it turns out this one executes very fast. In a couple nanoseconds, a division, a full-blown division with IDIV executes in many nanoseconds. I used to hold speed contest competitions. I haven't done it in a few years, but students would look for the instruction trick that would reduce a few nanoseconds. And then in the big million-time loop, that really counted for a lot. Okay. All right, so here you get a clean copy. This looks like a mess. Please program your final program using only things we learned. Don't drag in stuff from outside. Don't drag in stuff from FPU component. Those are the other floating point registers. Don't drag in ABX registers. You must have learned them somewhere, but for this test, stay with what we all know. Okay, I'm almost done with the programming. Let's, what was the rest of the agenda? Okay. Oh, so we should probably, on Tuesday, I'll talk a lot about concepts. We'll review the whole semester on concepts with no programming involved. Today, I want to get rid of the issue of programming. Are you good at passing arrays? Okay, from function to function. Okay, so part of your programming test could be passing an array. Let's suppose there's an assembly function up here, and it's going to, I need more space. It's going to declare an array. How should we say this? No, we're going to do it different. This one is going to call, it doesn't have the array, but it wants to call a function that makes the array and fills it and sends it back. So that's what we want here. This one is going to, we need a prototype. I don't know. Okay, so the prototype is, let's do double star get data. Oh, I see the problem coming. We won't know the size of this array. Okay. Okay, can you see what's coming, class? Here it is. This function up here, whatever it's called, manager, wants to call this one in C++, and it wants this one to create the array and fill the array and then bring it back to the manager. Okay, how can we do that? We got to have it's the size. This has to declare this for a certain size. We better send it the max size. So long max. Okay. So how could you do this? Okay, let's make double star array. Let's see. If this is C++, we would say equals new brackets max. Okay, now we're going to fill this. So we output message cout. Actually, I have this running. I'm going to show it to you. Cout, enter floats separated by white space. Press Control D to stop. Stop. Long sentence. Okay. All right. So how can we do this? I think it would. I shouldn't take a chance. It was while we need a counter. K less than max, and can I squeeze it in there? I don't know if it's going to fit. Scan F. What's our array's name? ARRAY K is, I better look it up. UF, I think that's it. And then K plus plus. And you declare K here. Okay, that smudges as misprint on my part. Oh, and then we say return, this is C++, return array. And we close that off. Okay, and in a moment I'll show you how assembly back here would call that and get it and save it in. Assembly has no name for it yet. Notice it's not declared in the .data segment. It's not declared in .bss. It has no name, but it still has to get it. I want to verify that I'm showing you the right syntax there. I think it's right. So hold on, everybody. Okay. No, where? I did this program. I forgot which folder. Hold on, I'll find. I forgot which folder I saved it in. Where is this guy? I think it is. Yeah, I think it is 2000. Teach. Yeah, and then it is 22. There it is. Okay, I think I have it here. Let's make sure. Yeah. Syntactically, you got a little. The idea is right. Let's fix it syntactically. Okay. Oh, that while loop. While the counter is less than max. Okay. And CANF. Obviously, I was missing this. That's because we're inputting float numbers, and we're going to put them directly into the array. And here's what I was missing. Scanf wants a pointer. It doesn't want hard data. So I have to do this array at K. Close it off. Not equal to EOF. And that's our loop stopping condition. And you notice it's in the condition that scanf reads a number, and if it's a valid number, it puts it in there, and it returns a true, and How does that work? It returns a true, and if the K index is less than the max, that's also true. A true and a true does not equal to EOF. I don't know how to say it any better. Scanf is pretty clever. If you press Control D, it returns a false, and a false ANDed with anything else, doesn't matter what it is again false. False not equal to EOF is actually, is that false? I don't have the words to explain this, but that works. I have a running proof. We'll run it in the last few minutes here. So that goes where this is, and then the body is just increment to the next one and return the name of the array. And in the function. Okay, I want to conclude it with, what does the caller do? So here's a function, and there's its data typing, and we want assembly to call that so that all the work of getting the array is done outside of the assembly program. Got it? Okay, so let's make this our conclusion. Okay, this is the block. To get an array. Okay. So let's move something. This is kind of standard. RAX is 0. There's no floating point registers involved here. So the prototype is one integer parameter being passed in. Okay, so let's move RDI. What's the maximum size we're going to allow? I'll just pick 20. There's nothing else. And then we'll call get data. Back to here. It's going to return not a double. If it was just to return a double, that would be XMM0. But it's going to return pointer to something. A pointer is, it goes to memory. So it's going to return a pointer to someplace. That's a 64-bit address. So we're going to get that 64-bit address in RAX. And now let's save it someplace. At this point, R13 is the array. So semicolon, R13, it is. There's no other special name hanging around for it. Is the array that was created on the outside and it was filled on the outside, the array. I have a flaw here, but we're not going to fix it now. I don't know how many numbers are in that R13. We know the max is 20. I don't know what the number that was actually entered there. Well, that's for another time. I'm going to run this program, and then we're going to conclude this class meeting. Let me move it where it's in our territory. So let's move. And you probably are expecting something about arrays in the programming test. Yeah. Where is it? Oh, we're right here. Okay, everybody is got to share the screen. Okay, so here is what I was talking about. And this, here's that loop that I was imitating, and plus the index gets plus plus, and it outputs how many has been successfully stored in the array. How many items have been stored? Anyway, we're going to run this, and again, I'm going to practice next class meeting something about arrays where the caller has the array and sends it to assembly. Maybe the caller is C++ and sends it to assembly. Let's go back here and and that's how, the last comment on that. That's how C++ handles a control D. If you notice that while loop will handle a control D coming. Let's run this now. So here. And the same program is available. It's online, and its name is what was its name? Its name Array Management, I think. I'll look it up to be sure, just in a moment. Okay, so what do we have? ls -l ssh r.sh. So the assembly has called this, and it's asking for numbers in this array. I think these were only integers. It says input a sequence of long integers. Okay, so we'll start with a 2. That's a long integer, and a 12, long integer, and an 8, and a long integer, and a 17, and a -1. Okay, and now let's use the control D. Here it comes. And they went back to, the array was passed back to the caller. The caller called a function to show it. And it has four columns. The cell number, he's just going to count it, where it's actually located, that particular number, which was 2.0, and here it is in its hex form. 400 is its stored exponent. And the next cell over, and they should be 8 bytes apart. You notice these very small numbers are growing by 8 bytes. Those are quad words in the array. And one number was, you know what, I actually, these are floats, aren't they? Well, there's a mistake. Long integers, they're supposed to say inter doubles. It's okay. Dijkstra said life is full of fixing errors. So I got to fix that word up there. Okay, so here's 12, and then here's 8, and there is 17, and there's -1. It all fits. So arrays are used a lot in assembly, and they serve purposes like if your function is to return 3 numbers. Normally functions return 1 number, but if you have to return 3 numbers, you put all 3 numbers in an array because you can return a single array like this one's doing. Okay, I'm all done. Any questions, anybody? We're just kind of reviewing old things. A lot of this came out of working program number 3. If you look back at it, that's the only one that we used this semester that had significant arrays in it. Okay. My program. There's some messages I'll have to handle at the end of class. Everybody, I'm finished with today's agenda. I'm just going to be here. You're on your free time. Work on program number 5, the last one of the semester. It is valuable stuff in there. That's okay. And actually, the rule about adding large numbers and small numbers applies to number 5. Nobody that I've read about that problem of finding the harmonic sum many times. I don't know if there's a known solution how to find it with perfect accuracy. It's a problem of adding a large number and a small number. And the small one gets chopped off a lot of times. Have a nice afternoon, everybody, and we'll see you next Tuesday. Okay. I'll be here until 4 o'clock if you have any questions about the past or the future. Okay.